Quadratic reciprocity. So before going to the law of quadratic reciprocity, let me introduce lemma. The lemma, let P be, lemma is, or we call this as lemma 1 for the quadratic reciprocity. Let P and Q be distinct odd primes, then sum from k is equal to p minus 1 by 2 to the least integer function kq over p plus k equals 1 to q minus 1 by p by 2 least integer function kp by q is equal to p minus 1 by 2 times q minus 1 by 2. Okay, so we are not interested in the actual proof of the lemma, but uh, we can verify this lemma by some integers. For example, so some prime numbers or p and q. For example, p is 7 and q is 11. Okay, so p minus 1 by 2 times q minus 1 by 2 is 7 minus 1 by 2 times 11 minus 1 by 2, which is equal to 6 by 2 is 3. 3 times 5, which is 15. Okay, and look at here. So let me compute these two terms as well. For p is equal to 7 and q is equal to 11. So sum k equals 1 to p minus 1 by 2, which is 3, k q. So q is 11 here, time over p. P is 7, least integer function. So we apply sum here. So this will be, when k is 1, so this is 11 by 7, plus when k is 2, so this is 22 upon 7. When k is 3, so this is 33 by 7. So least integer here is 11 by 7 is 1 point something. So least integer is 1 here. Okay. And 22 by 7. So least integer is 3 because 7 times 3 is 21. And least integer is 4 here. So when we add them, we will get 8 here. So similarly, k equals 1 to q minus 1 by 2, which is 5. K p means k times 7 divided by 11. So when k is 1, we will have 7 by 11. When k is 2, 14 by 11. When k is 3, so this is 21 by 11. When k is 4, 28 by 11. When k is 5, so this is 35 by 11. So 7 by 11 is 0, 14 by 11 is 1, 21 by 11 is again 1, 28 by 11 is 2, and 35 by 11 is 3. So 1 plus 1 is 2, 4, 4 plus 3 is 7. So 8 plus 7 is 15, so which is right hand side. Okay. So why we compute least integer function? Because if we have if we look at k 11k over 16, or here 7k over 11, okay, so we can sketch a line. Okay, for example, this is x-axis and this is y-axis, and let me consider this one. Okay, so use a different color. For example, 11k over 7. So let me write y equals 11 by 7 x. Okay, so this line passes through the origin, okay, because this line has no constant term with slope 11 by 7. So one point is here, okay, and when x is 7, okay, then y is 11. So this is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 somewhere here. Okay. Then we can have this line. Let me write point here. And the equation of this line is y equals 11 by 7x. Okay. So if we make boxes, 1, 2, 3, 4, 5, and then vertical boxes. Okay, so these are, so 1, 2, 3. Okay, and in this case 1, 2, 3, 4, 5. Okay, so here we have how many points or how many integers here in this box? So 1, 2, 3, and 1, 2, 3, 4, 5. So there are 15 integers here. Okay, so this line divides into two parts. Okay, so 3 times 5 is 15 here. Okay, so this is given here, and this line divides all integers or all lattices into two parts. One part is 8 and the other part is 7. So if we count them, so 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and 1, 2, then okay, why we are counting 0? Because 0 is because we will start from here, so 0 are not included. So 1, 2, 3, 4, 5, okay, 1, 2, 3, 4, 5, 6, and 7. Either this one or this one, it depends. Actually, uh, my sketch is not accurate, so that's why we are not getting exact values here. So there must be one more point below this line and 8. So 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 points above the line. So 8 points above the line, or 8 lattices above the line, or and 7 are below the line. So sum is again 8. Oh, sorry, sum is 15. Now move to law of quadratic reciprocity. So let P and Q be distinct odd primes, then Legendre symbol of P times Legendre symbol of Q over P is equal to minus 1 to the power P plus P minus 1 by 2 times Q minus 1 by 2. So this is called law of quadratic reciprocity, and this law has many applications to compute the Legendre symbol. Okay, so we will discuss the application. I am leaving the proof of law of quadratic reciprocity as an exercise, and then we will move to the application of law of quadratic reciprocity. Okay, inshallah, in next session. Allah Hafiz.